Okay, calculate the delta H. Calculate the delta H for the synthesis, this means formation, of dinitrogen pentoxide gas, N2O5, from its elements. Okay. Elements. So the reaction that we want is nitrogen gas plus oxygen gas goes to N2O5 gas. Now we have to balance this. So we have 5 and 2, so we'll put a 5 here, we'll put a 2 here, and we'll put a 2 here. Now it's balanced. This is the equation that we want, okay? Now, here are the equations that we have at our disposal. Equation number 1, we have H2 plus 1/2 O2 goes to H2O. The delta H of that is equal to minus 285.8 kilojoules. Our second equation is N2O5, plus H2O goes to 2HNO3, which is nitric acid. The delta H of that is negative 76.6. Exothermic, exothermic. 3, we have 1/2 N2 plus 3/2 O2 plus 1/2 H2 goes to HNO3. The delta H of this is equal to minus 174.1 kilojoules. So our task is to take these 3 equations, manipulate them by multiplying by coefficients, reversing them, and then adding them straight down, arranging them in such a way so that when they add to the final equation. Okay, so let's see what we've got. What can we do? I notice I have N2O5 on the right, and here I have N2O5 on the left, so let me just leave that one alone for now. Let me see, I've got 2N2 on the left, 5O2. I have 2N2, and the only equation here that has N2 in it is this one. So I'm going to multiply equation number 3 by 4. So multiply number 3 by 4, and what I end up with is, when I multiply the third equation by 4, I get 2N2 plus 6O2, plus 6O2 plus 2H2 goes to 4HNO3, and the delta H also gets multiplied by 4, negative, so this is multiplied by 4, minus 696.4 kilojoules. So whatever I do to the equation, I do the same thing to the enthalpy. Okay, now let's see what I've got. I'm HNO3, I have 4 HNO3, but I don't have any HNO3 here, so I need 4 HNO3s on the left. I have 2 HNO3s here, so I'm going to flip this equation and multiply it by 2. So we'll flip 2 and multiply by 2. So when I flip this and multiply by 2, I get 4 HNO3 goes to 2N2O5 plus 2H2O, and now the delta H for this, I have flipped it and I've multiplied it by 2, so now this is a positive 153.2 kilojoules. And now, number 1, let me see. Number 1 equation, H2, I've got, what have I got? I've got 2 H2s on the left, I've got an H2 here, I need to cancel the H2s, I've got 2 H2Os on the right, I have an H2O on the right here, So I've used equation 3, I've used equation 2. I need to get this on the left, and I need to multiply it by 2. So I'll do the same thing. I'll flip number 1 and multiply by 2, and I end up with the following equation. I get 2H2O goes to 2H2 plus O2. And again, the delta H is going to be plus 571.6 kilojoules. And now, should end up with what I've got. So let me see here. So we are concerned with this equation, and this equation. So let's see what cancels. H2O, 2H2O, 2H2O, 2H2, 2H2, right? This is on the left of the arrow, this is on the right of the arrow. They're on top of each other, but it's where they are on as far as the arrows are concerned. I have 4HNO3, 4HNO3, 2N2, yeah, so I'll bring that down. So that takes care of the 2N2. I have 6 oxygens on the left. I have 1 oxygen on the right, so 6 minus the 1 leaves 5 oxygens on the left. So that's taken care of, and that's taken care of. Now the only thing left is the 2N2O5, which is on the right, so I'm not adding it. Nice. That's on the right-hand side of the arrow, so I get 2N2O5, which is exactly what we want. 2N2 plus 5O2 goes to 2N2O5. That's exactly what we found. And now let's just add the delta H's straight down, and when we add them, we end up with 28.4. And again, you might want to check my arithmetic. I'm notorious for lousy arithmetic. So this reaction, nitrogen gas plus oxygen gas to form dinitrogen pentoxide, it is positive 28.4 kilojoules. So this is endothermic. That means in order for this reaction to go forward, I actually have to add heat to it. Or if I leave it alone and there are in another circumstance where there's something happening, there's enough heat that it can pull from the surroundings, it will pull that heat from the surroundings in order to make this go. So there you have it, Hess's law. We want to find the enthalpy, the heat of a given reaction. Well, if we have other reactions at our disposal that we know the heat for, and we can rearrange those equations in a certain way, we can fiddle with the enthalpies appropriately, add the equations, we'll get the equation that we're looking for, and we'll get the enthalpy of that equation. Okay, thank you for joining us today at Educator.com for the discussion of enthalpy. We'll see you next time. Bye-bye.